5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Monitoring greenhouse gases, including from space. That's our topic this week. We therefore have another Earth observation startup on the show as our guests, Airmo from Germany. They're developing an innovative instrument including LiDAR to track greenhouse gases. Founder CEO Daria Stepanova joins me to explain their technology and market in more detail. Enjoy! Hey space enthusiasts, welcome back to another episode. My guest today is Daria Stepanova and she's the founder and CEO of Airmo. Welcome, Daria.
Thank you. Great to be here.
Daria, the way we start this is usually the same. We ask the entrepreneur for a so-called elevator pitch. So if you don't mind.
Yeah, sure. So we are Airmo and we are driving decarbonization using power of space data. And while our mission is to bring transparency to climate monitoring and reporting, we see our first task is around cutting methane emissions. Methane is actually one of the key drivers of global warming and climate change, responsible for 1/3 temperature rise on our planet. More than 12 million assets worldwide require constant, continuous monitoring, and we still know only 30% of our methane footprint. That results in a huge loss for the industry, up to $30 billion yearly lost in leakages, in pipelines, in oil wells, and so on. And huge threat of fines. Largest fine last year reached $250 million. So at Airmo, we building solution to bring transparency to methane footprints. We develop sensors. We're experts in sensors and processing from the sensors. Currently, we're deploying them on drones and planes. And our big goal is to launch a constellation of 12 satellites to enable daily global monitoring of methane. And we pinpoint methane emissions down to facility and source level, helping energy, oil and gas, petrochemical customers to keep track of the emissions.
Okay, great. Thank you for that. So, well, actually, let me take a step back. So, where does the name Airmo come from?
It stands actually for air monitoring, short version. Yeah. And it's great. It starts with A. So we're in all the lists, we are quite high.
And that's elegant, and I assume that the web domain was available, so that makes a lot of sense.
And it was available, indeed.
Perfect. And so, how did you decide to do this? Do you want to talk a little bit, just briefly, about your background and what ultimately led you to start a basically methane monitoring company?
Sure. So I'm an aerospace engineer by my background. I studied very hardcore heavy tech from control systems, space systems management. I did PhD in theoretical mechanics applied to space. My PhD thesis was around optical comms. So I've been exposed to lasers quite early in my life, space lasers. I was working in a satellite manufacturing company for 6 years. So I've seen also how the new space evolved, how satellites became small, fast to manufacture, and brought quite many opportunities around applications, and various applications. So space data applications were something that was interesting me. The opportunity to launch a mission and get certain data sets, certain intelligence from space.
Okay, so let's expand a little bit on the technology since you started talking about it. Sort of, please keeping in mind it's supposed to be a non-technical podcast, but so even on a high non-technical level, I think probably most of our listeners are aware that remote sensing has been around basically for 60 years or so, and there's quite a few instruments up there already in space, airborne instruments and so forth. Can you just describe a little bit on a high level what makes your instrument special?
Definitely. So we definitely have a very special instruments. In our constellation, we actually have 3 instruments on board. First is shortwave infrared spectrometer. That's a super established technology. Many large satellites, governmental satellites utilizing very similar technology, push broom spectroscopy. Their uniqueness in spectral resolution. So we go for very narrow spectral resolution. We look at very narrow spectral bands to identify methane features very precisely. And second instrument is atmospheric LiDAR. There we are, as a commercial company, we're pioneers in micro LiDAR technology. There are only 2 companies worldwide currently pursuing development of a LiDAR. And we're proud to be one of those. Atmospheric LiDAR utilizes laser as a light source. We're shooting into the atmosphere from 500 kilometers, detecting photons that have been reflected from aerosol particles. In that way, we can characterize the aerosol layers. And combining these two data sets together allows us to increase the accuracy of methane monitoring, increase the number of environmental scenarios where we can run the monitoring, so high aerosol loads, desert environments, industrial areas with high pollution. This is where current systems do not deliver reliable data, and our solution will be able to. So uniqueness in the instruments, first of all, is in each instrument, we have certain unique features, and the combination of these two is definitely something that makes us unique.
Okay, so we have to take a step back here again, non-technical podcasts and all of this. So spectral resolution, just correct me if I say something wrong, but I mean, really what we're talking about here is that you're trying to detect methane, right? And sort of every like substance, element, molecules have a spectral signature, and that basically the high spectral resolution allows you to reliably detect methane, correct?
That's correct.
Okay, good. And then I was going to ask you, well, that seems what you want to do, detect methane. So why do you have the other instrument? But you actually have answered that. The combination of both instruments allows you to detect methane on a more granular level, or whatever the right word is. Also correct.
That's correct. That's correct.
Okay, maybe you can comment a little bit on sort of the state of the art, because to my knowledge, there is because climate has been such a big topic probably now for a couple of decades or so. There are greenhouse detection mechanisms out there, but as you said, you are better, and you can explain again what better means here. So can you characterize this a little bit or give examples, sort of like illustrating how much better you are than existing state-of-the-art solutions?
Definitely. So something that what matters in our case is the number of the particles per million of methane that we can detect. And in that sense, with the first satellite, we can go down as 10, 12 particles per million. Per million? No, sorry, 10, 12 particles per billion of methane particles in the column of the atmosphere. So here, of course, we are comparable with such satellites as MethaneSat. MethaneSat has, I think, 8 to 10 particles per billion, but it's a huge satellite with a very, very big instrument. So for small form factor, this is it's a very good, very comparable performance. And the second is the conditions. So what are the conditions? What's albedo? What is the surface heterogeneity? What's the atmospheric state? The other atmosphere, the aerosol optical density in the column. So here we, in average, can reliably reach the sensitivity of the instrument in average in 50% more cases. And in some cases, such as, for example, again, higher aerosol loads in the desert environment that covers all the Middle East, we can reliably monitor in around 70% of the year. Comparing to what's existing now, it's around 20 days a year.
Okay, and does it also mean that, let's say you have a pipeline or something with a leak, that you could detect smaller leaks that otherwise would go undetected?
That's also the case. Our detection threshold for the methane it can go down to 50 kilogram per hour. So we indeed can see the methane leakages that other existing systems don't. The best performance up to date is around 100 kilogram per hour. So we're at least 2 times better in that sense.
Okay, and so maybe you can talk us through to kind of make this more visible and tangible, sort of like a customer use case. Maybe it's a pipeline, maybe something else, whatever you think sort of illustrates it best, sort of like how you come in, what you detect, and then sort of like what you actually give back to the customer. Like, I assume it's some sort of data, but if you could just walk through that.
Yeah, definitely. Here was worth mentioning that we're already commercially available with our drone and plane sensor. So we do have certain both relationship and a lot of experience working with the energy sector, especially. How we do it right now and how we will do that from space is following. So at the moment, we develop together the inspection campaign with our customers. We identify the area for monitoring, we identify the potential sources of methane. We execute campaigns, so we either fly with drones over the facility, the same with plane, covering the complete territory, mapping emissions sources on the map, quantifying emissions, so understanding how big is the leakage. and delivering this data as a report to the customer. So that's something we're doing now. With space, of course, we will be able to do that autonomously. So no need to send people, no need to send expedition to the customer sites. Everything can be done with limited manual work, but with the same results. So basically, map with emissions detected and quantified is something which, what is something what we deliver to the customers.
So one question always for remote sensing companies is the sort of distinction between the upstream and then the downstream analysis. Are you doing everything, or is the customer analyzing the data? Are you guys doing it? Is someone else doing it?
Yeah, so most of our customers do not have capacities to analyze the data. So the map comes together with just a table of emissions and inventory items that are emitting. So that it's a ready product that doesn't need to be processed further.
And so actually a few other remote sensing companies that ultimately want to be satellite companies. You guys are currently operating on planes and drones, and that makes a lot of sense for testing the instrument, and I guess maybe also for some use cases. I mean, sort of on a high level from a business perspective, do you want to walk through sort of why is that not enough? Why do you actually need the satellites?
We definitely need satellites for a couple of reasons. First is a unit economics. Satellites are the most cost-effective solution. While today we're planning our inspection campaigns, as we call them, they happen in Europe, in Middle East, in Central and Southeast Asia, depending on how far we are from Germany. The more complicated inspections become. Find the carrier, find the plane. Somewhere in Korea is quite challenging to do that remotely. We need we build in a strong partner network of drone and plane providers, but there's a huge overhead on every campaign in a new territory, in a new country. With satellites, within a day, there's a possibility to monitor pretty much any spots on the planet at affordable cost. And that's something that customers definitely want to see. Continuous monitoring is a second reason. Flying a drone every week would also be quite expensive for the end user, where weekly monitoring, again, on any spot on the planet is something that customers would like to see. So the trend for methane leakages monitoring, of course, the faster you detect the leakage, the less money you lose in the atmosphere. And the customers and the industry is incentivized to get data about the leakages as fast as possible.
And so sorry, asking stupid questions. Why do you have to monitor it as often as weekly? I mean, just intuitively it seems like, okay, there's maybe some leak, something happened with a pipeline. Okay, now it's leaking. Okay, thanks to you guys, that gets detected, it gets fixed. Is it really going to break again like a week later, or is there like so many such a high need for maintenance that like a week later it may break somewhere else, or is that just like an industry standard, like that's a given?
Yeah, so based on the EPA reports, it's the organization in the United States that gets the overview on all the costs, savings, and environmental issues. Reducing leak duration from 1 month to 24 hours can save up to $80,000+ per event in average. It makes sense to detect and fix the leak as fast as possible, not to actually lose money for the end customer. That's the major reason.
And so we'll come back to that when we talk about sort of the market and the rationale for the customers. But just sort of finishing up some of my understanding or our listeners' understanding on the tech side. So I think you mentioned before you want to get to a constellation of 12 satellites.
That's correct.
I assume those are what's called low Earth orbit satellites. So can you just walk us quickly through the rationale, like why 12?
Right. So with one satellite, we can monitor any spot within a week revisit rate. Again, an average, depending on the latitude. With the 12 satellites, we'll be able to deliver daily revisit rate on any spot, and that's something we see that customers would like to have, daily monitoring of certain types of assets. Yeah, and then also number of facilities that we can monitor. There's a cap on every satellite, how many points during the day we can cover. So to cover a big portion of the market, we need 12 satellites.
Okay, and roughly what kind of size of satellite are we talking about here? I mean, you kind of were contrasting it to Methane sat, which you described as something like very, very big. So I assume this is something relatively much smaller, but if you can kind of give any sort of more non-confidential details so our listeners can imagine.
It's a 50 kilogram form factor satellite. It's a bit bigger than the CubeSat. The instrument itself weighs 17 kilograms. It's also on the other side. It's quite power hungry. A laser needs quite a lot of power on the output to receive enough signal back. So with that in mind, 50 kilogram is a perfect form factor for us.
Understood. And sort of talking about again about sort of how you monitor with those ultimately 12 satellites, or even if it was just one satellite, since you're working for specific customers, I assume this is what in the industry we call it's all tasked, sort of like you know what you're going to be looking at rather than sort of
Yeah,
taking a broad sweep of looking at an entire region, correct?
exactly.
Okay. But so one related question, I guess that's sort of a segue, and then we talk about market and sort of how you make money on all of this is I mean, low Earth orbit satellites, they spend a lot of time by definition over regions where there's maybe nothing to see, like oceans and things and so forth. Is there, and then on the other hand, you have your specific customers you're tasking the satellites for. Is there, so for the time you're not overflying specific assets that your satellites are tasked for, is there something else, since you have this really nice fancy instrument, is there something else you can use it for? Is there something you guys have thought about?
Yeah, we did think about. We looked at the oil spills, for example, on the ocean. We didn't really look too deep in that, but with visibility for shortwave infrared spectrum, there is certain possibility for oil spills. LiDAR can be used over territories where there's no energy infrastructure over land to map aerosols and to get information about pollution. So that would be the side use case that we'll be experimenting with the first satellite. And for subsequent satellites, we also want to install the multi-channel LiDAR to get wind data and wind correction. So the big problem in quantification of methane emissions is wind, and uncertainty that wind brings. Basically, yeah, we don't know where the wind is blowing and what affects the plume. So how does it evolve in time due to wind? So having collocated information about wind speed and direction together with methane concentration can significantly boost the quantification precision. So here also with wind, wind would be great to measure pretty much everywhere to get small footprints of wind data. This is relevant also for weather forecasting, to some energy use cases, to planning of the trips and planes, so the transportation use cases. Yeah, but wind will be a bit later.
Understood. And I'm just listening to this and I just realized again, sort of the non-technical podcast thing. I should have asked you much earlier to actually give the 1 minute explanation for non-technical listeners what LiDAR, or like a reminder what LiDAR actually is.
Yeah, LiDAR is an active remote sensing instrument that utilizes laser as a source of light. We are shooting laser pulses down to the atmosphere, and laser is reflected as it's reflected from the walls, or we also use LiDAR in cars for range detection. Here, light is also reflected from aerosol particles, from the small particles in the atmosphere. So in certain wavelengths, and now we selected 1.5 micron, we can characterize this aerosol layers in the atmosphere by just counting photons, detecting this reflectance signal from aerosol boundaries. Yeah, so we basically measure intensity of the signal from reflected laser and the time that has spent between issuing the pulse and receiving the pulse. So it's very similar to like standard LiDAR, with the only difference that we shoot into the aerosol particles, very small particles, and detect the light back coming from particles.
Okay. And sort of thinking about the Earth observation remote sensing, like satellites in general, unless I'm wrong, I think this is sort of like the last instrument that was missing, right? So obviously we started with optical cameras, and then infrared has been around for a long time. Things like radar have been around for a reasonable amount of time. More recently, that's what we call a hyperspectral. But LiDAR seems to be sort of the most recent one and the one that was missing, right? And is that because of what you mentioned, that it's just not trivial because it has high power requirements and all of that?
Definitely, I think one of the last ones to be commercialized. And indeed, it's very interesting to see what will happen to the remote sensing and if there are more LiDAR companies will appear. As any other space tech remote sense instrument, it was belonging before to the governments. There's a big group in ESA working on LiDAR technology where our chief scientific officer is coming from. The second company is based in the United States. There's also a big scientific group in NASA that has been developing LiDAR technology for altimetry, a bit different use case. So I would say, yeah, it's the time for this technology to be commercialized. There are many issues around thermal, around stability, around like all the influences on optics. Like we need special lenses. The LiDAR itself is quite a large instrument. So that's from design perspective, it's not a trivial instrument as well.
Okay, but the core, if I understand correctly, the core technology, because of bigger, probably very expensive government satellites, has been demonstrated and to some extent de-risked.
Definitely. So IOLOS, one of the most successful satellites from European Space Agency with LiDAR. There's a bit of it's a bit different LiDAR. It's a different type, different wavelengths. EarthCare is the second, also very successful satellite from the European Space Agency side that have demonstrated that LiDAR from space makes sense.
Okay, understood. Okay, so let's talk about a little bit about so enough about technology, even though that's very exciting. Let's talk a little bit about markets. And so on a high level, you already described why customers may want to do that, and sort of we've talked a little bit about things like leaks and losses that may generate. So I get that, but I think in the introduction you also mentioned something about fines. Do you want to expand a little bit about on that, please?
There are definitely very interesting also time we live in when around regulations and fines. So there are several groups of regulations that frame the work of energy sector. There are several groups in the US that now experiencing quite challenging time. There's a big regulation in the European Union that has been adopted last year. It's called EU Methane regulation that obliges all the energy sector, every energy related company to actively measure emissions coming from the infrastructure. So every company in Europe now has to run leak detection and repair campaigns either 4 times a year or 2 times per year, depending on the type of the infrastructure, and monitoring, verification, and reporting campaigns once a year. So these two, like this is a Bible now in Europe that from 2027 will be also expanded to all importers of oil and gas in Europe, meaning the rest of the world that is interested in selling gas and oil to Europe will have to also follow the same rules. And the companies, so something similar has been set in the US. Now it's been challenged, and we'll see what's the destiny of this regulations in the US. I guess in this year. But for non-compliance with these regulations, so not submitting reports, submitting wrong reports, companies either penalized already or will be penalized. And the biggest fine for non-compliance last year reached almost 250 million. So can be quite painful.
Okay, it would have been better than to pay less than $250 million to Airmo. I get that. But so if it's okay, the part about you mentioned where it's non-compliance by not reporting or delivering wrong reports, or maybe there is a, let's say again, this simple example of a leak somewhere and that just doesn't get reported. I mean, at the extreme, and let's say it's a region where there is a regulation in place. So how does the regulatory agency know? Like, it seems like they would need someone like Airmo too.
Definitely, and we're very proud to also work with such organizations as Greenpeace, Deutsche Umwelthilfe, it's a German environmental agency, to run verification campaigns. So regulators definitely also need a tool to run verification campaigns and to see if things are correctly reported. I think here we should definitely acknowledge the large satellites that share the data with the largest NGOs such as environmental defense funds or RMI. They share the data with Mars and UN. So these data sets, they first give us an understanding that numbers in reporting and reality are significantly mismatched, and we need to have more granular outlooks. And then the satellite has like our there are several other satellites that have capabilities and capacities to run methane monitoring. We can look much more narrower, much better to locate the hotspots of these events, of the emitter events.
Okay, I keep on using this like simplistic, stupid example of a leaking pipeline, but I should just ask you, like, what are sort of typical use cases and kind of following on from there, who are actually like your likely target customers?
So in use cases, pipelines is a perfect example. Absolutely, pipelines can last for thousands of kilometers, and it's very challenging to like assess in which part of the pipeline, in which segment of 200 kilometers there's a leakage. It's a good example. Gas storages, refineries. Here we've seen the cases as methane is leaking from valves. So due to movement of the ground, transportation, some valves in pipes get open. It's very stupid, but sometimes there's a lot of methane leaking just because the valves are not closed. Extraction of oil and gas, so oil wells, gas wells is the third. LNG terminals, loading, offloading gas, liquefied gas. Flaring is another big problem that is from this year also banned in the EU. This ban will be expanded from 2027 also on the importers to EU. But yeah, flaring is the burning the excess of methane during the processing of oil and gas. Yeah, these are cases that we can help our customers with.
Okay, and then so by logical interpretation of that, that means probably a very big customer group for you is sort of like the energy industry, pipeline operators, oil companies, oil and gas companies. And then I guess like we just mentioned also the potential like regulators, whether it's official government regulators or non-for-profit groups monitoring these types of things.
Yeah, exactly. So our longest customer and biggest partner in crime is TotalEnergies, for example, is a large tier one oil and gas company. We working with Uniper, it's a big gas operator in Germany. We also have some smaller customers, smaller local customers with gas storages and pipelines as well in Europe. So it's starting from large oil and gas, going to utilities, pipeline operators. But that would be the first segment, the first target group that is on one side experiencing the product loss and money loss due to these leakages. Second, there's a push from regulations to act, expanding from energy and oil and gas, who could benefit also petrochemical, cement, steel, landfills, agriculture. We have, for example, a company that we're working with a chicken farm. There's a biogas station company. The broader market is much bigger than only energy.
Okay. And I guess it's also, in some ways, very nice because, I mean, we've had quite a few Earth observation companies on this podcast, but very often they're from the US. Very often it's sort of like, oh, maybe ultimately we do something commercial, but basically right now we're selling data to the Department of Defense. So it seems like you guys are a little bit different there, that you're actually starting with a like viable, justifiable, real commercial use case, real commercial demand.
Exactly, and I think it was a very right strategy, right decision to shrink the instrument, try to test it on the airplane. That's something we've done again together with our first customer, TotalEnergies. And at some point we realized that there's a definitely interest and definitely need, and we should spend more energy on commercializing that one. And it's precious to work with the end user, understand like in the fields to understand all their needs and understand all these details about infrastructure. That helps us a lot to shape the product for the satellite use case.
Okay. And ultimately, how will you guys make money? And sort of, I understand right now, probably with those aerial campaigns, it's sort of project by project, roughly speaking. But once it's sort of a satellite constellation, is it basically like a subscription model, kind of taking into account the, I don't know, square kilometers monitored, or how would this work for the customer and for you guys?
Definitely. So it's already today. It's as monitoring has to occur with certain repetition rates. we enter into multi-year contracts with our customers, where the final price for the inspection is calculated by kilometer square of monitoring. So for our customers, there will be a very minor change in the dashboard where they receive the data from inspection campaign. There will be just only one new extra data source of the satellite data will appear. So I think the subscription-based model where customers paying per kilometer square of monitoring is more or less already in place. It will be just one more data stream integrated.
And is it okay? You don't have to answer this if you don't want to answer this, but sort of like thinking about the kind of two different interesting customer groups again. On one side, the actual like let's say the oil and gas companies. On the other side, potential like regulators, whether they're state actors or non-for-profits. I mean, would you be able to sell the same data to both Total and then like Greenpeace, or is there sort of like Total has like the exclusivity and then you can't give it to Greenpeace anymore?
So it's a very very interesting question indeed. We will not be reselling the same data sets to different parties, and the one who is the first one to decide around monitoring for a certain area will be getting the service. But we stay neutral. We do not take any sides, neither industry nor regulator in that sense. And I would say at this moment, working together with regulators helps us to expand their network with customers, because they also understand that, like the regulator might ask us to do another inspection campaign on them, and they better know in advance what's going on with their
So it's
infrastructure.
like they should be motivated to get the data first. Kind of like
Exactly.
Yes, that's very interesting. Okay, cool. So what's your sort of execution plan? Like, where are you right now? I guess you said you're doing aerial campaigns right now, but ultimately you don't have the satellites. When are you going to have satellites? And then what are sort of the next major milestones?
Definitely. So we have a very active, busy summer. As reporting and monitoring timeline in Europe is quite aggressive. We basically fly in almost every third day within the different pieces of Europe. We're working towards the satellites. We plan to launch one in the end of the next year. So our current instrument TRL is 6 for spectrometer, so it's quite advanced. We're now preparing for manufacturing assembly and tests, and for LiDAR currently TRL 4. So we're working hard on bringing the TRL of a LiDAR also up to speed. We have a year and a half to complete this mission.
And the satellite you'd be flying end of next year, if all goes well, that's sort of like would be the first type of the, one of the 12, or like, is it a prototype, or how would you characterize that?
It's definitely going to be another demonstration mission. We'll see how successful it be. The ideal case, of course, is just to replicate the payload further and launch constellation straight away. That's normally doesn't happen from the first time, so there will be likely an improvement on both instruments. But again, here our airborne campaigns, they give us a lot of learnings, a lot of So airborne campaigns give us a lot of experience and teach us a lot on data processing, on system engineering level. So I guess in that sense, we're confident that in a year and a half we can launch a mission.
And if that all goes well with the first satellite with the demo mission, what's your rough timeline to get to the full constellation?
By 2029, 2030, the complete constellation.
Okay. And is the 12 really it, or is there some scope of like why you may need more, or there could be a benefit to have even more satellites?
Very, very interesting question. So for methane use case, as we see it is at the moment, 12 should be sufficient. With the same technology, we can run monitoring for other trace gases, CO2, NOx, could potentially become interesting, and we would definitely explore these cases after we're done with methane. But technology has, as we discussed, also other applications. Wind is something we want to pursue. So here, depending on our timelines and how we will be able to get technology up to speed, we might consider more satellites for other applications. And wind is very interesting, of course, for us.
Okay, cool. And so if all goes well, let's say, you know, 10 years out, that's the right time frame. What's your like ultimate vision for Airmo?
Uh, right. So the ultimate vision is to deploy 12 satellites to enable daily revisit on any spots on the planet to help bridge this 70% of unknown methane emissions to bring this percentage of unknown emissions down, and then pursue other cool applications of the technology. That would be.
I guess there's sort of a larger question that I sometimes ask myself, but I don't have a good answer, which is sort of like where is the entire remote sensing industry going, right? Because we have some larger players with more traditional instruments now, and some of them, you know, have a few hundred million of revenue. Some of them are publicly listed, but there's still, apart from this, there's still quite a few companies with different sensors and everything. And then they still have this, to some extent, you also have still a distinction between people who are doing upstream, some people who try to do only downstream, just the analysis part. Do you have any sort of view of like vision or, I don't know, even like wish where the entire Earth observation industry should be going?
Uh, Very interesting question. There's definitely, I would say, there's definitely some place for very vertical solutions, very verticalized solutions that pursue certain use cases. And I would say Airmore here belongs to a very vertical company. There's definitely like horizontal slicing of what is doing in certain just data stream without going deep into the cases. I believe that uh, going deep into customer problems has a shorter path to success in comparison to the horizontal one. And on the larger picture, uh, I guess that there are so many intersections between these two, and they all need to end up somewhere in solving some unique problem. So on the big picture, I would say Earth observation community should be working together on understanding how to map all these data streams and how to engage the users into building together products. I think that definitely one problem that is existing is that the actual data is very far from uh, um, solutions. Application layer is not yet
Mm.
developed enough. But here, I think everyone should work together on particular cases, and that's something where we should, as a Earth observation community, aim to go.
Yeah, it seems like the exactly what you said, the I don't know what the right word is, like the user friendliness of the data or the ease of access and the ease of analysis is just very nascent still and could be a lot better. And so hopefully that will change over the next few years. And maybe, you know, some people foresee a lot of industry consolidation and maybe that will help in that as well. I guess this is like this discussion is sort of a nice segue into our usual two final questions for every episode. The first one is if you weren't doing Airmo, but like you know, you've got quite a bit of work history in the space sector, as you've explained. You're working on satellite integration and you know, having an aerospace academic background. What else do you find interesting in the commercial space sector?
I do have one more area that I find quite exciting is space habitats, and I'm really very much looking forward for nuclear microreactors to come when the more opportunities to experiment with habitats in extreme environments on Earth, and then consider Moon and Martian habitats. So that's definitely the if I wouldn't be doing Airmo, this is the area I would find myself.
Okay, fair enough. And last question is always the same, which is about favorite science fiction. If you like science fiction, what are some of your favorites? Could be books, movies, TV series.
Yeah, I love Three Body Problem, all three
Mm,
books. That's a great exercise for imagination, for recapping physics under source of Chinese culture. I find it completely cool.
yeah, fully agreed. I read the trilogy myself and I would recommend it to anyone. It's a very dense, very long. I think each book has about 700 pages, but it's mind-blowing. So it's definitely worth reading.
Yeah,
Cool. Daya, thank you so much for coming on. Best of luck to Airmo with everything you're doing. Very exciting, very exciting. Again, commercial use case for Earth observation for a change, and one where you seem to have really good traction already. So congratulations on that, and best of luck going forward.
Yeah, thank you. Thank you for the invitation. It was great to be here.
And that's it for another nominal episode of the Space Business Podcast. And once more, if you enjoyed this episode, please leave us a 5-star rating on your favorite podcast platform, such as Apple or Spotify. You can follow us on Twitter at podcast_space. We're also on LinkedIn under the Space Business Podcast. Lastly, if you have any feedback, including ideas for guests, and that may even include yourself if you have an exciting space story to tell, or interested in becoming a sponsor, or really for any other suggestions, you can drop us an email at spacebusinesspodcast@gmail.com. Thanks so much for listening, and see you for the next episode.